Welcome everyone to the Wellness Institute of Dallas's presentation on bacteria and gut health. This is Dr. Rayner and I look forward to presenting this material to you. It's a very important area of research as of late. It's very expansile and it's continuing to grow because they're starting to find that the bacteria that we have in our GI tract has a huge impact on our overall state of health. So we're going to start off with some general information about just the GI tract and kind of drive home some fundamental things. The GI tract is a very big barrier system. From a standpoint of comparing it to other systems, our GI tract is 200 times the surface area of our skin. So you can tell it's pretty important in terms of keeping foreign things out of our bloodstream. And this is a huge reason why our body dedicates 70 to 80% of our overall immune system to call the GI tract home. In particular, the GALT, or the gut-associated lymphatic tissue, which makes up 60% of our immune system, is just one portion of the immune system in our gut. The mucosal associated lymphatic tissue, also known in short as the MALT, makes up the other 10%. In addition to that, 80% of our immunoglobulins, which are the carrier proteins of the immune system, 80% are found in the gut. This is important. I mean, our body dedicates a bunch of resources to making sure the GI tract is strong and has no potential weaknesses. Another part of that story is the bacteria that makes up our GI tract. We're going to get into more and more detail about the bacteria in our GI tract, but we need a good line of defense, which means we have to have a good competition of healthy bacteria lining our GI tract. So if any bad guys sneak in, they can't basically replicate and make a stand because there's so many good guys that start to suffocate them. So if you don't have a pen and paper, grab one. We're going to go through a lot more information here. Press pause and we're going to start to move on through some more key fundamental information on bacteria and the cultures in. All right, let's start off by looking at some common conditions that are associated with actually poor gut health and potentially poor bacteria species in the GI tract. First, chronic fatigue syndrome. Second, depression. There's actually a lot of research about depression and how its origins actually stem from issues in the GI tract. Type 1 diabetes, cardiovascular disease, autoimmunity, and various other autoimmune conditions throughout the body, not just autoimmunity in the GI tract, inflammatory bowel disease, obesity, and type 2 diabetes, and a handful of pediatric disorders like allergies, asthma, autism, Asperger's, and ADHD. These have all had research that correlated these issues and diseases with poor gut health. Looking at the very word probiotic, it translates into meaning pro-life or life promoting. And a probiotic is a microorganism that is introduced into the body for its beneficial qualities. We obviously benefit the bacteria, and the bacteria gives us benefits, or else it wouldn't be a good relationship to keep having going forward. And this is very important to understand that there are good bacteria, probiotics, and then there are bad bacteria that we need to limit in our GI tract. This next slide goes over some probiotic trivia. You can always pull this out at a dinner party. But there's over 400 different species of probiotics that exist in our GI tract. Now, only 30 to 40 species actually account for 99% of the bacteria. This is wild. Now, another crazy fact that when I tell people I kind of get a weird look at, but there's anywhere from 2 to 9 pounds of bacteria in the average human being, with the overall average being about 7 pounds of bacteria. This makes probiotics one of the largest functioning organ-like systems in our body. On top of that, for every one cell we have in our body, there's 100 bacteria. Now, crazy numbers, so they have to be beneficial to us, or why would we allow our bodies to develop with these bacteria? Looking at some of the immune system benefits that good bacteria and probiotics provide is very important because there's many. One, like we said already, good bacteria help compete against the bad guys. It's actually been found that they create a biofilm that lays on top of our mucus lining of our GI tract, which is very, very hard for bad bacteria to come in and penetrate. That being said, though, if we have a GI tract with bad bacteria, they can also create a biofilm, and a biofilm that can actually become resistant to antibiotics. The good bacteria, they also help increase antibody production by our immune system. They also help regulate and decrease proteins of our immune system that promote inflammation. Probiotics also help convert plant-derived chemicals that we can normally not break down unless it wasn't for the bacteria into enterolactones. And the cool thing is that low levels of enterolactones have actually been associated with certain types of cancer like breast cancers and cancers of the GI tract. In addition to the immune benefits of probiotics, probiotics also provide essential nutrient production for our body. They help produce valuable nutrients like vitamin B and the various B vitamins and vitamin K, biotin, B12, folic acid, which is B9, pantothenic acid, which is B5, pyridoxine, which is BD6, and riboflavin, which is B2. All come from metabolism of the good bacteria in our GI tract. They also help produce various amino acids and also short chain fatty acids that in the right amount help feed our GI cells. It would make sense that if probiotics provide nutrition for our body, that they would also help in digestion to provide those nutrients. So they do so by releasing digestive enzymes. These digestive enzymes help our body break down plant fibers that we otherwise wouldn't be able to break down. And when we break them down, we break them into products called short chain fatty acids. These short chain fatty acids help feed 70% of our GI tract to help it heal, grow, and be strong. The only thing is in excess, too much short chain fatty acids can actually cause spikes in blood sugar and fat production. We'll go through how that happens in a little bit. Detoxification is a huge area for our body's health, and when we have impairments, you see our health decline. Now, the main goal of our detoxification pathways in our body is to remove waste and toxins and excrete them. And the cool thing is that probiotics actually help improve our body's detoxification pathways. One of our main pathways as humans we use is called the cytochrome P450 system. And what this does is it helps the majority of our waste and toxins get out of our body. The neat thing is that bacteria have a similar enzyme system. And when these good bacteria increase these enzymes, it signals in the blood for our liver to increase our own enzymes, thus increasing detoxification. The other thing that probiotics help us do is they also act like a natural chelator, and they help with exposures to heavy metal and making them less toxic to our body. And one last thing good bacteria do, they increase levels of butyric acid, which is one of our short chain fatty acids, which has been shown to be related and correlated with anti-tumor activity or cancer prevention. Very, very important stuff. If we're trying to create an environment for bacteria that actually help us, we need to know how do we create the environment for the ideal bacteria. This environment would be one that is low in starch, low in sugar, low in animal fats, but high in plant fibers. There's lots of research that shows that people in rural Africa that mostly eat high amounts of plant fiber, they have some of the best GI cultures, and this is really interesting because they've been the subject of a lot of research. High sugar, high carbohydrate, and low plant-based diets promote the growth of a lot of bad gram-negative bacteria that can actually be very detrimental to our health. Knowing what creates an environment for good bacteria, let's look at the consequences of having an environment full of bad bacteria. Now, research has shown the following. One, bad bacteria environments in our GI tract increases triglyceride or lipid profiles for the worse in our blood. It also creates changes in brain centers that are involved with basically satiation and fullness and hunger. You also see changes in gut permeability or leaky gut syndrome as a result. This is because bad bacteria release something called lipopolysaccharides, which are very detrimental and inflammation promoting in our body. This also in turn promotes insulin resistance as a downstream side effect. You also see decreased muscle fatty acid oxygenation, which in turn hurts our metabolism. You'll see the bad bacteria increasing fat production and blood sugar production, only worsening blood sugar stress and obesity. And overall, bad bacteria, like we said, increases inflammation as a basically a response of blood sugar issues, the lipid polysaccharides on top of that. The main thing to take away from this is that the research is profound, that bad bacteria is starting to be correlated with more and more health issues. And we're going to start to go through and kind of piece through some of the research that depicts this. So let's look at our first research article about good bacteria and gut health. Now, this is, from my standpoint, this is a very powerful research article because it has many other articles summarized within it. It's called Functional Interactions Between the Gut Microbiota and Host Metabolism. It was published in September of 2012. And the biggest thing is it shows that gut bacteria is increasingly being accepted as an environmental factor that affects the host and can be associated with different things like obesity, diabetes, and cardiovascular disease. Now, when you step back and if you see obesity and diabetes, it's really important to know that those two things there are involved with many of the top causes of death in this country. Now, I'm not saying that bacteria directly cause them, but if it has a role in it, you need to be, as a healthcare provider, looking at it as a potential source of treatment or a potential intervention point, because what we're going to show you is that gut bacteria can in fact cause obesity and diabetes. So this picture here is actually one from the article we just kind of mentioned, and it's a very good diagram because it kind of shows you the chain of events that leads to basically issues with health. So basically, say something like bad diet causing bad bacteria species, antibiotic use, all these things have been shown to create the wrong type of bacteria in your GI tract. What this leads to is altered fermentation and a change in the energy harvest. So we mentioned those short chain fatty acids earlier. Well, there's three main types that our body will produce. Those are acetate, propionate, and butyrate. Butyrate is the ideal one because it has many health benefits. But when our body has bacteria that are very efficient at promoting acetate and propionate, you start to see health effects come into play. You'll see issues where we start to have increase in liver production of certain things like triglycerides and inflammation, fat generation. You'll see inflammation throughout the body in fatty tissue and muscle tissue. You'll see increased permeability of the GI tract, which opens the door for a lot of inflammation. And as a result, you'll start to see issues and changes in leptin and ghrelin, which are two hormones that help create the balance between hunger and fullness in our body. So you'll start seeing issues with basically cravings and foods, all as a consequence of the wrong bacteria. Very powerful slide, and it kind of shows you some very interesting things that can happen as a result of just the wrong bacteria being in your GI tract. This is another great figure and picture diagram from that article we're still discussing. If you look to the left, that's the liver, and at the very bottom you'll see lipopolysaccharides. Remember, lipopolysaccharides are produced and created from the bad bacteria in our GI tract. Now, as we increase the number of lipopolysaccharides, you'll see an increase in something called TNF-alpha, tumor necrosis factor alpha. Doesn't matter, just know that it creates inflammation through our body. Research shows that tumor necrosis factor alpha is involved with the diabetic nerve pain, numerous other conditions, but it's a big stimulatory protein that creates downstream inflammation and can lead to systemic inflammation in our body. Now, you can see on this slide on the right, it's just showing that how tumor necrosis factor alpha can actually lead to GI issues like leaky gut. Now, we have a whole separate presentation on leaky gut and gut issues, but just know that something simple as the bad bacteria can increase this inflammatory protein that can then hit the bloodstream, travel through multiple sites of your body, creating inflammation. Now, this figure from the research article kind of just shows the colon on the left and the liver on the right. And again, when we have too much of the wrong bacteria, instead of making the right amounts of short chain fatty acids, we have things short-chain fatty acids being produced in excess, and particularly the ones that we don't need that much of, like acetate and propionate. What these do is they go on to produce other processes in our body or stimulate them, in particular lipogenesis, which is fat generation, and gluconeogenesis, which is sugar generation from things other than a sugar molecule. Now, this has a huge role in terms of promoting obesity and insulin resistance, because the more fat we have, the harder it is to get blood sugar into the cell, because we are becoming insulin resistant. So this last figure from the research article we're still on has two different categories: independent effects of the bad bacteria and the dependent effects of the bad bacteria. So let's start off with the left-hand side. We've already kind of mentioned the lipopolysaccharides. They go through this whole process where they can promote insulin resistance. They also increase things called peptidoglycans, which can be very basically fat promoting, which in returns can promote insulin resistance, diabetes, and obesity. Going to dependent effects, when we look at certain byproducts produced, you look at choline production being changed, which in turn can promote things like cardiovascular disease. Cholesterol, you'll see that being affected, especially if we have changes in our lipid profiles as a result of changes in liver function due to increased stimulation of short-chain fatty acids to the liver. And again, let's look at polysaccharides to short-chain fatty acids on the right. Very good energy source, but at the same time though, when we have higher amounts of propionate and acetate, you can see those short-chain fatty acids being used to promote inflammation instead of actually helping against it. Alright, so this next article we're looking at here looks at how antibiotics shape our GI tract's bacteria species. So when we take antibiotics early in life and we deliver them to mice in a mice model study, what you see is a change in the colon's species of bacteria, so that it actually promotes changes in short-chain fatty acid levels, which leads to basically fatty liver, lipid profile changes, and cholesterol production. As a result, you'll see obesity-like traits start to appear, and you'll see increases in fat deposition. And again, we know all of these can basically promote insulin resistance and many, many other health effects, all as a potential consequence of antibiotics early in life. And that's what this research article shows, that antibiotics are enough to shape the GI structure drastically enough to cause a long-term change. So this next article, published in 2008, has already was actually referenced in a lot of our other articles, but I'm going to go through and describe it because it is pretty fundamental at the time when it was published. What it did, it had basically obese mice and lean mice, and then you had this neutral group that was germ-free or bacteria-free, and what they did was they took so many mice and put the fecal bacteria from obese mice in some of the germ-free mice, and then they took the lean mice and put some of their bacterial species into these germ-free mice. And what they found, that the obese mice, when they basically transferred those bacteria to these neutral species, that these mice in as little as 2 weeks became 2 times as fat as the mice that received the bacteria from the lean donors. Pretty profound and pretty quick turnaround. This research has gone on to lead a lot of other research, like the one we've already mentioned above, but it is very, very fundamental, and I had to share it with you because it was pretty interesting. Now, stepping away from the probiotics and their role in obesity, we're looking at an article that was published last year in July of 2013, and how basically different bacteria cultures are found in the autistic child. Well, they found that a lot of kids with autism suffer from GI issues, and they're like, why is that? Well, what they found was that the diversity of the bacteria cultures in children with autism is much less than the healthy child. And what they showed, that there are certain strains, like the ones that are in the title of the article, that are much less represented in the autistic child, and that they found that these strains of bacteria are very, very beneficial, not only for the healthy GI tract, but for the basically monitoring of inflammation in the body, and that they found that these things as a result may actually contribute to some of the autistic like symptoms. But the authors also note that they don't know if it's a consequence of autism in the first place that causes a change in the GI spectrum of bacteria, and vice versa. Either way, though, the purpose of the study was just to shed some light on that there is a difference in bacteria cultures, and that this may be something that needs to be looked at with children with autism, that you need to help repopulate their GI tract with the right type of bacteria. So we're coming to an end of this presentation. I kind of want to wrap things up. Now, we've gone through different research articles and different things that have been kind of associated in research with the wrong type of bacteria. And the main thing is we need, for the most part, the general public has heard about probiotics. What we need to do is take this information and help educate others about all the different effects probiotics have been shown to have. And that was kind of the purpose of this presentation, is kind of hopefully open your eyes a little bit about the different effects they have, and two, maybe think about somebody that you may know in your life that actually may need this or may need to have this evaluated. From our standpoint, this is one reason why we test stool a lot in our patients, because it's important to know what's living in your GI tract, just because the implications this can have on your health. Now, again, I mentioned earlier that, obesity and diabetes is the leading cause of death. When you look at all its potential health effects, like it can increase your incidence of stroke and cardiovascular disease, Alzheimer's, and all those conditions are in the top 10 causes of death in the US. So when you look at this, if we can do something simple like changing the type of bacteria in your GI tract, and this can have a profound effect on you avoiding those conditions later on, or a loved one or a friend, then it's simple. Take the necessary steps, get good bacteria built up, change your diet so you limit the bad bacteria, and you start building this army of good bacteria that actually go on and promote many, many health benefits. So I hope you guys learned a lot of information from this, got some idea that there is actually a lot of research out there on this subject matter. This is only a scratch of the research we have. There's many more I have at home, at the office. If you want more, you're interested in some more, we're going to be publishing some research summary articles on different bacteria cultures and their research articles on the webpage. But if you can't wait for that, just shoot me an email or shoot the office an email like listed on the slide below. I appreciate you guys taking the time to listen. If you have any questions regarding this this presentation, just let us know. We will be happy to answer them. And then start to look for the next presentation to kind of follow up on this, which is going to be to do with gut health in terms of leaky gut and what that is and what that means for you. Okay? I hope you guys enjoy this and learn some valuable information.